Alright, on this question we'll be doing sets. It's actually the question from the 2018 past paper. The topic is sets. So the question is 1.3. Check that one out. So how do we work out this problem? First we are given this equation. 3 to the 9x is equal to 64. And we are also given 5 to the root of p equal to 64. So they want us to determine this ratio. The ratio of 3 to the x minus 1 all cubed and all over the square root of 5 to the root of p. So how do we do this? Obviously we can be guided from this alone that we'll have to manipulate this equation in order for us to get the numerator, and also the denominator we have to manipulate this equation. So how do we do that? First let's start with this. We will say therefore we have 3. By decomposing this further, we can actually get the cube root of this because that's the simplified form of it. So we can say 3, the cube root of 3, let's say 3, or by simplifying it by saying 3 to the, let me say, in order for us to multiply exponents, we say 3 to the 3x, and then it has to be 3. We multiply it by 3 in order for us to get 9, equal to the cube root of 64. Cube root of 64 is the same as 4 to the 3. So now since exponents are the same, we can conclude. It also implies that we can conclude that 3 to the 3x is the same as 4 in this case. So we're done with the first one. We come to the second one. The second one, we will say this: we have 5 to the root of p, which equal to 64. So by getting the square root of this, both of them, it implies that we will be having the square root of 5 to the root of p, which is going to be equal to the square root of 64 is equal to 8 in this case. So going further, we can tell from the ratio itself that the 3 to the x minus 1 has to be the numerator, so we have to divide the 2 and then manipulate until we get to this ratio. How do we do that? We will say divide the ratios that, the equations that you have. We have 3 to the 3x, which equal to all over, let's say all over, you say root of 5 to the root of p. This is going to be equal to, it's going to be equal to 4 all over this 8. So already we have 1 all over 2. So how do we manipulate this to get to this point? Basically, this is the main concern. Okay, looking at this, I can see that we have 3 to the x, also 3 to the minus 1. This here, when you simplify it, you get 3. The inner part, we have 3 to the x multiplied by 3 to the minus 1. And of which this is the same as 3 to the x all over 3, since this one is 1 all over 3, right? So now it implies that in this case we have to multiply by what? In this case is cubed, meaning that we can multiply this out here and also this one out here. So we have 3x minus 3. Agree? So now it implies that in this case we have to multiply by 3 to the 3, basically. So if I multiply by 3 to the 3, matter of fact, it should be negative 3, so that we get negative 1. So now let's do this. We will say multiply both sides. It means this is the same as 1 all over 27. Because it's more of saying 1 over, expressing this as a positive exponent, we have 1 over 3 to the 3, which is the same as 1 over 27 basically. So that's why if we multiply both sides by this, and then both sides, we have this, which is the same as that. So going further, it implies we have 3 to the 3x, right? 3 to the 3x multiplied by what? We multiply it again by 3 to the minus 3 all over the square root of what? Of 5 to the root of p. I hope you get that one. So now continuing further, it's more like we actually just multiplied the numerators because this is the same as over 1. So 1 multiplied by the root of 5 to the root of p, it still gives us the same thing. So how do we do this? This, by looking closely, is the same as the numerator of that. Why am I saying so? Because this is the same as, if we get to simplify here, we have 3 to the 3 multiplying bases of the same exponents. Multiplying exponents of the same base, we add the exponents. So we have 3x minus 3 all over root of 5 to the root of p, which is equal to, if you take out the common factor at the top, or you can actually factor out an exponent of 3 by so saying 3 to the